Okay, guys, I want to go over some of the position, speed, and time graph information that you need to know. This problem is from your assignment 1.6. It's on the backside, part 2, the first position versus time graph. We're going to analyze the position versus time graph, then turn it into a speed versus time graph, and then analyze that one as well. Okay, so let's start right here. Okay, it's a position versus time. Hours are on our x-axis, miles are on our y-axis. Okay, and let's go ahead and start by kind of chunking this graph. Okay, you'll notice a chunk going right here where his speed is consistently changing for that first hour. Okay, you'll notice a chunk right here where he is stopped. Okay, we know that because his position isn't changing. Okay, so obviously he is stopped, he is not moving. Okay, then there's another chunk right here and another chunk right here, both representing different movements. Okay, I'm going to go ahead and label these chunks 1, 2, 3, 4. So let's go ahead and start with chunk 1. Okay, in chunk 1, his position is changing. Okay, he's going from 0 to 15 miles. Okay, in 1 hour. Okay, so we can calculate his speed during that time. Okay, his speed is going to be 15 miles distance over the time, 1 hour. Okay, so he has a constant speed throughout that time of 15 miles per hour. Okay, because the slope is constant. Okay, it's not a curved line, it's not curving down. Okay, it's not doing anything weird. Okay, we know that the speed is constant. So in this section, he is moving at 15 miles per hour. Okay. In section 2, okay, this section right here, he is stopped. We know that because the slope is 0, which means the speed is 0. Okay, so in this section, he is going 0 miles per hour. He is stopped. Okay, now let's look at section 3. Okay, this one right here. In section 3, his position changes from 15 miles to 30 miles over from 1.5 hours to 3 hours. So in 1.5 hours. Okay, so we can calculate his speed in that section as 30 minus 15. He's going 15 miles in 1.5 hours. Okay, notice the slope is not changing. Okay, so let me pull out my calculator here, and 15 divided by 1.5, I get a speed of 10. Okay, so he is going 10 miles per hour. Okay, which makes sense. The slope is a little bit more gradual than this slope. He's changing his position more slowly, covering less distance. Okay, so he's going slower. And our last section is part 4. Okay, part 4 goes from 3 to 5.5 hours. And he goes from 30 miles to 40 miles. So if we're going to calculate the speed there, it is 30 minus 40. He goes 10 miles in 2.5 minus 3 in 2.5 hours. Ooh, he must have been going uphill on this one. Okay, he's going pretty slow. So when we plug that into our calculator, or you can solve it in your head, 10 divided by 2.5 gives us 4 miles per hour. 4 miles per hour. Okay, so now we have completely analyzed our position versus time graph. We know his instantaneous speed at every part of the graph. Okay, so we're ready to take this and turn it into a speed versus time graph. Okay, we're gonna have the same chunks. Okay, in the first hour, he was going at a constant speed of, I'll do this in green, of 15 miles an hour. And then he stopped for an hour, okay? His speed went down to 0. Okay? Chunk 3 went until we hit 3 hours. And during that chunk, he was going at a constant speed of 10 miles an hour. Okay? And then until he got to 5.5 hours, that's when his bike trip was probably over, he was going at a speed of 4 miles an hour, so a little bit below the line that represents 5. Okay? And there we have our speed versus time graph. Okay? This graph on the left didn't show any changing position, okay? It didn't have any curves, so there was no acceleration. That's why all of our slopes on our speed versus time graph are flat. Okay? Because there was no acceleration shown. He just instantly changed his speed. Why not? Okay? And that's how we analyze our position versus time graphs.